In this session of metrology and instrumentation, we are discussing on accelerometers and vibration sensors. Accelerometers and vibration sensors have got a common feature that most of these systems are utilizing the mass spring damper system configuration. That is, the accelerometer will have a mass, a spring, and a damper in the system. If you take the case of any vibration, we know that the vibration will be continued because of the spring action, and the mass will be oscillating, and finally the mass will come into the center neutral position. During the vibration, if the force is removed, the mass will eventually come to the neutral position by slowly reducing the amplitude of vibration. The amplitude is getting reduced because of the damping feature of the mass that is being vibrated. Because of this reason, the equation that explains vibration will have three forces, like a mass, that is the mass force, there is damping force, there is spring force. So the force given that for causing the vibration will be distributed for the movement of the mass, for damping of the force, and for spring action of the force. Because of this reason, all the accelerometers or vibration sensors are modeled by a spring mass damper system kind of model. In this, mass is called as inertial mass or seismic mass. Take the case of an acceleration that is happening practically. Take the case when you are moving in a bus which is moving at a particular speed. When the bus comes into stop suddenly, you will feel a forward movement unknowingly because of inertia. Here you are acting as an inertial mass and you are experiencing the reaction of sudden stopping, that is a sudden deceleration. Take another case, you are sitting behind your friend in a bike, and the bike is suddenly accelerated by your friend from stop, you will unknowingly go backward because again due to the inertia, that is inertia due to rest. There you are acting as inertial mass again. That means if there is acceleration or deceleration, there will be a reaction experience on the mass, and that mass is called as the seismic mass. Now the movement of the mass is an indication of the acceleration or deceleration experienced by the system. Now let us take one example or construction of accelerometer where strain gauge is used for sensing the movement of the mass. Here the construction of a strain gauge accelerometer, here it is. There is a cantilever beam. At the tip of the cantilever beam there is a mass, this is the inertial mass, and on the cantilever beam there are strain gauges attached on either side. That means if the inertial mass moves, the cantilever beam will be deflected. So if one place is experiencing a compressive force, another surface will be experiencing tensile force, that is opposite to each other. Here there are two options, like there can be a fluid inside the casing that will act as a damping fluid, or the property of the cantilever beam itself will be acting as a damping feature. This cantilever beam will be made of spring material. That means in this system we have a mass, inertial mass, there is spring as well as damper. Now you are attaching this accelerometer on the body for which we have to sense the acceleration. Suppose this object is moving in the upward direction, the inertial mass will have a reaction in the downward direction. When it moves downwards, the deflection, that is x, that is happening is an indication of the acceleration in the upward direction, and because of the reaction this mass goes down, and that will cause a bending for the cantilever beam, and that bending will be taken by the two sensors, that's a strain gauges placed on either side. These strain gauges will be part of a Wheatstone bridge. When there is a movement of the mass, the Wheatstone bridge and the connected voltage will vary. That variation is an indication of the displacement of the mass from the neutral position, and that gives the acceleration of the body in one direction. Same is the case if the body is moving in the downward direction. There the reaction for the mass happens in the upward direction. Now, you have to notice one particular thing about this arrangement is that this particular seismic mass is sensitive only in this vertical direction because of this orientation. That means accelerometers are direction sensitive. If you want to sense acceleration of this body in this direction, it is incapable of sensing it because there won't be any reaction in this direction. So if you want to sense acceleration in the horizontal direction, you have to attach the accelerometer such that the inertial mass is like this and it moves in this direction. Then it can sense the acceleration in that direction. Now let us see the construction of a piezoelectric kind of accelerometer. The construction is here. What you see is an accelerating body. There is a casing, that's a base. The base is attached with the accelerating body. There is piezoelectric crystal here. On either side of the piezoelectric crystal, there are electrodes, and there is a mass. This is a seismic mass. You can see a cap here, the green cap here. The cap is typically made of spring steel. Now, in the construction, the spring steel cap will be rotated such that it will be tightened against the thread that is shown here. That means when you fix it towards the base or to the base, the spring steel material will be forcing this mass downwards, and a squeezing effect happens, and because of that the piezoelectric crystal will be experiencing a compressive force. So in the assembly itself, this piezoelectric crystal is preloaded in this case. Now let us see the working of this accelerometer. Take the case where the accelerometer is moving in the upward direction, say upward direction. When it is moving in the upward direction, what happens is this mass will be experiencing a downward force reaction. That downwards reaction will be acting more force on this piezoelectric crystal. The crystal will be developing charge, and you eventually get an output voltage on the circuit. The output voltage is a reflection of the mass, the force applied by the mass on the crystal, and that directly connected with the movement of the body in the upward direction. Now, if the body is moving in the downward direction, what happens is this mass will be released, force will be released because it's moving in the upward, the reaction is in the upward direction. Since this accelerometer was preloaded, in that case the force on the piezoelectric crystal will not be relieved totally, and that is why we have preloaded the crystal by pushing this cap inside the base. Now when it moves downward, this mass will go upward, and that will cause a change in the force that is applied on the crystal. Again, when there is a change in force, there is a charge developed, and that charge will give a voltage output, and that voltage is an indication of the movement of this. Now we have seen the acceleration sensing by sensing the movement of a proof mass. How this can be utilized to sense vibration? We know that vibration is a time dependent function where displacement of a mass will vary with reference to time. So in the same arrangement, when the body moves upward or downward direction with reference to time, what is the change in voltage that is given out? That change in voltage with reference to time is an indication of movement of the mass upward or downward depending on the direction, momentarily direction change during the vibration. So this same arrangement can be utilized to sense both acceleration as well as vibration. So depending on what output we take from this arrangement, that will define whether we are utilizing it as an accelerometer or we are utilizing it as a vibration sensor. These two vibrations accelerometers arrangements are contact type. That means these accelerometer arrangements are actually fastened to the body on which we have to sense the acceleration. Now let us see another kind of accelerometer or vibration sensor, which is a non-contact type. One example is laser Doppler vibrometer. Here they utilize a laser beam and we utilize the Doppler shift to sense the movement of a body. Body means here it is named as a target. So this is a vibration or moving body. The movement of the body is sensed in the photodetector. In this laser Doppler vibrometer, there's a laser source. There are beam splitters, 1, 2, 3 beam splitters. There is a Bragg cell. It is an acousto-optic device. That is, it can generate sound, a change in refractive index by providing sound. That's a Bragg cell. There is a mirror here. There are photo detectors. The functioning is the laser beam that comes here, that will be split in two directions. A reference beam will be going in this direction, another beam will be going in this direction. So because of the acousto-optic effect, another Bragg frequency will be introduced in the reference beam, where again there's a beam splitter. One part of the frequency will be going this direction and falling on the target material or object. Another will be going here, and this F0 plus FB will be joined with F0 like this. Okay. Now the object when it is subjected to a laser beam, this object will be reflecting the laser back, and that will go here and it goes back to the photo detector. Actually it's a interference counting device. It's an automatic device which will count the number of fringes. Now if the object moves in this direction or in this direction, there will be a frequency shift, or the Doppler shift happens for this frequency, and the Doppler shift is introduced here in this case. So the Doppler shifted frequency will be going here and that is falling here. This particular accumulated frequency is compared with the reference frequency in this photodetector, and that is an indication, the difference is an indication of the movement of the target. If the movement of the target is sensed here in a time domain, what we get is a vibration. If the movement is sensed for a particular moment, that shows the acceleration. So this arrangement can be utilized for sensing both vibrations and acceleration. So this is a non-contact type of vibration sensor. More details are given in the learning material and it is available in the academic management system. If any questions, you can directly post in our discussion forum and I will be happy to assist you to give the answers. Thank you.